Welcome. This is my monthly update of solar activity for February of 2021. This is a summary of what we're going to cover today. We had 14 new sunspot regions, 13 of which were from solar cycle 25, which is 93% of the sunspot regions that appear are from the new cycle. 9 were in the northern hemisphere and 4 were in the south. Does this mean that the northern hemisphere is all of a sudden starting to wake up? I hope so. We had only 13 spotless days in the month. The sunspot numbers range from 0 to 34, with an average over the month of 8. This is a lot less than we had in November and December. We had 4 C flares, and I noticed 7 CME in the Coronal data, 3 to the east and 4 to the west. The solar wind has been highly variable this month. As you can see from the density plot, it's averaged about 10 particles per cubic centimeter, but varying everything from 1 to over 50. The speed of the solar wind has also been highly variable. Generally, when the speed is above 500, the magnetosphere is considered to be active, and when it's below 500, it's supposedly quiet. You can see there's been several periods through the month when the solar wind has been above 500. As far as the temperature is concerned, that has varied everything from about 10,000 degrees up to about 500,000 degrees, and all that depends on where on the sun the solar wind is originating. Let's take a look at the sunspot number in the context of the last few years. This is from solar cycle 24 primarily, and just everything from December of 2019 onwards is solar cycle 25. What we have plotted here in yellow is the daily sunspot number. The blue is the monthly average sunspot number, and the red is what's called the smooth sunspot number, which is where you take a boxcar of 13 months and smooth it over the monthly sunspot data to get a more uniform curve. And that shows that the maximum of solar cycle 24 was in April of 2014. We can see that solar cycle 25 is taking off rapidly, and within 11 months it surpassed the sunspot number that solar cycle 24 had achieved in nearly 2 years. Well, let's look at some movies. We're going to start with the sunspot movies. We get that from the Solar Dynamics Observatory HMI instrument. That's pictures effectively of the photosphere, which is a temperature of about 5,700 degrees Kelvin. Sunspots are dark because they're cooler at about 4,700 degrees Kelvin. These are full disk images, and 1 second equals approximately 1 day. Next, we'll take a look at the magnetic sun using the same instrument, but using its magnetogram channel. Magnetograms have a convention that white indicates strong magnetic fields that are moving towards you, and black indicates strong magnetic fields that are going away from you. These strongest areas are generally associated with sunspots. These are full disk images again, with 1 second equal to approximately 1 day. Next, we'll take a look at the transition region. This is the region of the solar atmosphere where the temperature rises very, very rapidly and the density falls off equally quickly. This we watch with the Solar Dynamics Observatory AIA instrument and look at its helium-2 304 channel. The temperature of the material you're seeing is about 50,000 degrees Kelvin. These again are full disk images with the same cadence as before. The flashes that you see during the video here are when the Earth gets between the satellite and the Sun. This usually happens near the equinox. Next we'll take a look at the corona. This is the low temperature corona. For that we use the AIA instrument again with the iron 9 channel at 171 angstroms. The temperature here is about 630,000 degrees Kelvin. These are full disk images and 1 second per day. Note how dynamic it is even in the quiet corona. Next we'll take a look at the high temperature plasma, flare plasma. This is about 6.3 million degrees Kelvin. This is in an iron 18 line at 94 angstroms. You'll probably see lots of little flashes as this movie goes by. Those are flares of various sorts. The brighter ones are the C flares that I talked about earlier. Last but not least, we're going to look at the outer corona. This we use a different spacecraft, the SOHO spacecraft, and the LASCO C2 and C3 channels. These are full disk images plus a very large extra space. You can see that white circle in the middle is the size of the sun that we've been looking to up to now. These large bright areas moving away rapidly from the sun are what are called coronal mass ejection. You'll see some bright areas to the north of the image in the first few frames. This is because the background wasn't taken away properly, and that will make some imaging very difficult to see. There are going to be two repeats. The first repeat, I suggest you look at the east limb, which is the left limb, and see if you see any CMEs blowing away from the sun. By the way, in the movies I didn't notice any comets. Maybe you'll see some that I missed. Now this is the second repeat. This time look at the right hand side, which is the west limb, and see what CMEs you can see there. Let's take a look at the solar cycle 25 flares so far. The blue flares marked here are C flares from solar cycle 24. Remember, the minimum was in December of 2019. To the right of that, we have marked in orange the C flares from solar cycle 25, and the green are two M flares, which are much larger flares that we've seen in solar cycle 25. Now, it took nearly 2 years for solar cycle 24 to see the first M flares from this cycle, but we managed to achieve that in 6 months from solar cycle 20. Again, an indicator that solar cycle 25 is likely to be a larger cycle than solar cycle 24. So what is my prediction for solar cycle 25? Here's the graph you saw for solar cycle 24, and so I'm going to mark on here where solar cycle 25 is as far as I'm concerned. That egg-shaped oval is where the bullseye is. It's a peak of about 165 with an uncertainty of about 30, and solar max will be in May of 2024, again with an uncertainty of about 6 months. Even though the model I show here in dash is smooth, it's not a smooth rise. You'll get several bursts of activity leading up to the maximum. The question is, when will the northern hemisphere start to kick in? We have many predictions so far. So here again is my prediction. I put it with the blue cross on here. The NASA NOAA prediction is about the same as the last cycle and much later in 2025. Zarkova, who we've talked about before, has a predicted maximum of 100, but in 2022. I think that's highly unlikely. Hathaway, who usually produces a lot of predictions, has a prediction rather similar to that of the NASA NOAA panel. McIntosh, who's always a little bit aggressive in his predictions of solar cycle, is true to form and is predicting something in the low 230s. And then we have a lot of other predictions by Bowmilk, Wu, Hilal, and Pesnell, who 5 of those crosses are his as well. And I could fill up this whole area with other predictions. The size of those crosses, by the way, don't indicate the uncertainties on the plot. But basically, they're all grouped around the 120 level, which was the solar cycle 24 maximum. So very few of us are predicting higher cycle than the other ones. So the main conclusion I have here, this is a great time to start observing the sun. But set up to do it safely. There's lots of guides online. Never look directly at the sun, especially through a telescope. And so you need to have special filters on the telescope or use projection method like shown here in the background to see the sunspots. Take photographs if you can, and you can use that to work out your own sunspot number each day and see whether it's following the prediction that you make from this solar cycle 25. Happy observing. Until next time, goodbye.